Hello students, welcome back to today's class on quadrilaterals, and we are in the lecture number 2. Yesterday we discussed what is a quadrilateral and what are the different types of quadrilaterals, and today's class we are going to have some more discussion on that, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So let's try to start with the one question here. The four angles of a quadrilateral are in the ratio 1:2:3:4. Find the measure of each angle of the quadrilateral. Okay. So we don't know what are the angles, but the angles are in the ratio 1:2:3:4. So the property behind this is sum of all the angles. Sum of all the angles, right, in a quadrilateral is equal to 360 degrees. So now, as it was given in the ratios, let us take the angles as 1x, 2x, 3x and 4x. So total 4, 5, 6, 7, 8, 9, 10x. The total 10x should be equal to 360 degrees. So x should be equal to 36 degrees. Okay. So this is not the side. This is not the angle. Okay. This is not just one single angle. So with one side 1x is 36. Next 2x, it is 2 times of 36, which is 72. Next 3 times of 3x, 3 times of 36. Let's try to multiply. 6 3s are 18, 3 3s are 9, 10, 108, and 4 times of x, 4 times of 36, which is a 144. Let us add all this. 36, 72, 108, 144, 8, 9, 10 and 20. So 7, 8, 9, 10, 11, 12, 12 plus 4, 16. Yes, that is 360, right? So that is how we try to find the values of the angles when it is given in terms of ratios. Not only 1:2:3:4, not only x, 2x, 3x or 4x, we have a lot of other things also, right? So based on the given ratios, whatever the ratios are given, just try to add them and try to equate that to 360, try to find the value of x, and then you can get the remaining angles. Okay, so leaving all this, let's come back to the next concepts. Every parallelogram is a trapezium. The question is this correct or wrong? Is it yes or no? Every parallelogram is a trapezium. I told you, trapezium means only one side, one opposite pair of sides should be parallel. This one and this one should be parallel, not equal. They are in parallel, okay? But in parallelogram, both the pair of opposite sides are parallel. This one and this one, and this one and this one. So are these two same? No, right? Every parallelogram is not a trapezium. Every parallelogram is not a trapezium, right? Let's move forward for the next one. All parallelograms are quadrilaterals. Yes, of course, a parallelogram is quadrilateral. You can have any type of parallelogram. A four-sided closed structure or four-sided polygon is always considered as a quadrilateral, and we can say that it is yes. Right? Next one. A square is a rhombus. Do you know that? A square is a rhombus. See, what do you have? What you need to have a rhombus? Rhombus means all sides are equal. All sides equal, right? A rhombus. So in a square, do we have that structure? Yes, definitely. A square is a rhombus. Yes, definitely a square is a rhombus. So we can say that it is yes. But the next coming thing is a bit tricky. That is, every rhombus is a square. So we need to show that whether it is correct or wrong. Every rhombus is a square. See, rhombus means all sides are equal. That is okay. But what about square? In square, all sides are equal. Okay, all sides are equal, and every angle is 90 degrees. Every angle is 90 degrees, which is not true for rhombus. So every rhombus cannot be a square. Every rhombus cannot be a square. A rhombus in which the angles are also equal to 90 degrees, that becomes a square. So now the answer is no. Every rhombus cannot be a square, but every square can be a rhombus. Okay. Next one. All parallelograms are rectangles. All parallelograms are rectangles. No. In parallelograms, it's okay. Like these are opposites are parallel, but in rectangle, we should also have the right angles, 90 degrees angles. Okay, which is not correct for all the parallelograms. So all parallelograms are not rectangles. So answer is again no. Right, straightforward. Okay, right. So let's come back to some of the beautiful numerical applications based on all this what we have discussed. Okay, so ABC is a triangle. Let us try to draw that. One second. So we have ABC as a triangle. And what ratios are given here? Let's see what ratios are given here. D is a point on AB. D is a point on AB such that AD is equal to 1/4 of AD. AD is equal to 1/4 of AB. That means if complete AB is 1 unit, AD is 1/4 of that. Okay. In other sense, I can write AB is equal to 4 times of AD. AB is equal to 4 times of AD. That means if I take AD as X, AB, this complete thing will be 4X, and this DB is equal to 3X. That's enough. Right? But don't write X and 4X here. It is with respect to AB, not with respect to DB. The same way, and E is a point on AC such that AE is equal to 1/4 AC. AE again, AE 4 times of AE is equal to AC. 4 times of AE is equal to AC, right? So A is here. If AE is X, the total length will be 4X, and this will be equal to 3X. X and 3X, and the total is equal to 4X, okay? So if DE is equal to 2 centimeters, if DE is equal to 2 centimeters, if this length is 2 centimeters, then find BC. Now carefully observe, what is the ratio in which the triangles and the sides are splitted? For example, okay, as this is parallel, right? ABC is a triangle, D is a point, AB such that all the ratios, right? So these two triangles are in the equal ratios. I mean, say like X by 3X and X by 3X. So based on that, we can say that the triangle is similar, and DE is 2 centimeters. Now we need to find the value of BC. Now we need to find the value of BC. So how to get that? Yeah, so X and 3X. So what is AD by AB that was given? AD by AB is given as 1/4. AD by AB is 1/4. So in the same way, the base is okay, DE by BC should also be in the ratio 1/4 because they are in proportion. They are in proportion, right? So DE is 2 centimeters by BC. BC is X is equal to 1/4. So X is equal to 4 2s are 8 centimeters. X is equal to 8 centimeters. So this length is 8 centimeters. So using the basic ratios and proportions, you can directly solve that because the triangles are similar. Okay, next one. A diagonal of a parallelogram divides it into two congruent triangles. So it's a very beautiful point that you need to remember because many applications are based on this point. What is that? A diagonal of a parallelogram divides it into two congruent triangles, not into two equal triangles or two similar triangles. Congruency. Congruence is being maintained into two congruent triangles. You can see here, this is one triangle ADB and the triangle ABC, and you can see that angle A here will be equal to angle C here, this pink color, and these two angles will be equal to these two angles, and obviously the third angle will also be equal. Right? So these two triangles are congruent triangles, and you can say AC is a diagonal. What is a diagonal? Diagonal is a line passing through two opposite vertices, or not other than two adjacent, which is not a side. For example, I'll give you for a pentagon. For a pentagon, I'll tell you all the diagonals. Okay, other than the adjacent sides joining, all the other joinings are diagonals. Okay, so this is a join, this is a diagonal, this is a diagonal. I cannot join this one. So from here to this is a diagonal, and this is a diagonal, right? And from here this is a diagonal, and this is a diagonal, right? So in that way, you can try for any figure. All the sides, excluding all the sides, the remaining all the joinings of any point to any point will always be diagonals of that polygon. Okay, so here we have one diagonal. Generally, for a quadrilateral, we'll be having two diagonals. What is the other diagonal? The other diagonal will follow like this. Okay, that is the second diagonal. Okay, a diagonal of a parallelogram divides into congruent triangles. A very beautiful approach, right? Next one. In a parallelogram, opposite sides are equal. Yes, that is exactly correct. In a parallelogram, as these two are two congruent triangles, so this side and this side should be equal, and this side and this side should be equal, and this is the base which is common for both of them. So in a parallelogram, opposite sides, these two sides are equal as well as these two sides are equal, because we already saw that these two triangles are congruent. Because these two triangles are congruent, right? So we can say that here opposite sides AB is generally parallel to CD as well as AB is equal to CD. And we have one more, which is BC. BC should be equal to AD, or we can say that BC is parallel to AD. Okay, both of them parallel as well as equal. Parallelogram, the name itself says that the sides should be in parallel. Okay. The next point about all this parallelogram and their properties. So if each pair of opposite sides of quadrilateral is equal, then it is a parallelogram. If each pair of opposite angles, if each pair of opposite sides, you can see here. So this is one and this one, these two and these two and this one and this one. If all these are equal, okay. If each pair of opposite sides of a quadrilateral is equal, then it's a parallelogram. Once again, if each pair of opposite sides of a parallelogram, right? In a quadrilateral, each pair, so this one and this one should be equal and this one should be equal to this one. So it is enough to say that it is a parallelogram. Right? All the other structures, whatever we had discussed as a rectangle or maybe square or rhombus or kite, all these actually came from the basic structure of parallelogram. And depending on some variations of parallelogram, like different angles or different lengths of diagonals and all this, we come to a conclusion of different figures. But parallelogram, right? Every parallelogram, every figure is a parallelogram. Not every, but majority of the cases. A square can be considered as a parallelogram. Rectangle can be considered as a parallelogram, right? Yeah, wherever we have opposite sides of parallel, we can say that they are parallelogram. Next one. In a quadrilateral, if each pair of opposite angles are equal, then it is a parallelogram. The same thing, right? If each pair of opposite angles, let me see that. Right. If each pair of opposite angles are equal, then it is a parallelogram. Each pair of opposite angles are equal. So this line, this angle and this angle, and this angle and this angle should be equal to say that it is a parallelogram. It may be for any quadrilateral. Next one. The diagonals of a parallelogram bisect each other. It's a very beautiful concept. Diagonals bisecting each other. What do you mean by bisect? Bisect means breaking into two equal parts. Bisect means breaking it into two equal parts. Okay. So this is one diagonal and this is another diagonal. So these two diagonals bisect each other. That means both the diagonals midpoint is the same. Both the diagonals midpoint is the same. So this length and this length are equal, right? So the diagonals of a parallelogram bisect each other, and this two, this is a diagonal, this is a diagonal, these two will be equal and these two will be equal, right? So based on that, we can have lot of applications of a similar triangles concept here, because we can see lot many triangles involved in this one. So a question can be framed in any way, right? Next one. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. If diagonals of a quadrilateral bisect each other, just now we discussed that, right? If diagonals of a parallelogram, one second. The diagonals of parallelogram bisect each other. What is the next one? If the diagonals of quadrilateral bisect each other, then it is a parallelogram. The same point repeated twice, right? The next one. The opposite angles of a parallelogram are 3x minus 2 and x plus 48. Find the measure of each angle of the parallelogram. Once again, opposite angles of a parallelogram are 3x minus 2 and x plus 48, and in parallelogram these two are equal. In parallelogram these two sides are equal. So 3x minus 2 is equal to x plus 48. So 3x minus x is equal to 48 plus 2. 3x minus x is equal to 48 plus 2. 3x minus x is 2x. 2x equal to 48 plus 2 is 50. So x is equal to 25, right? This is the value of x, not completely. Then find the measure of each angle of the parallelogram. Now, one thing, opposite sides are equal and adjacent sides are supplementary. Adjacent sides are supplementary. Okay. So 3x minus 2 equal to x plus 48, 3x minus x equal to 48 plus 2, 2x equal to 50, x equal to 25. So to get this angle 25, so 3 times of 25 minus 2, 75 minus 2 is 73, right? And that is also 73. And we know some of the angles, side by side adjacent angles should be 180 degrees. So angle A plus angle D is equal to 180. Angle A is 73 plus angle D is equal to 180. So angle D is equal to 180 minus 73. So that becomes 107, right? So other angles are 107, and again vertical opposite, that becomes 107. Vertical opposite becomes 107. Okay. The opposite angles of a parallelogram are 3x minus 2 and x plus 48. Find the measure of each angle of the parallelogram. Okay. What's the next one? Find the measure of all the angles of a parallelogram if one angle is 25 degrees less than the twice of the smallest angle. One angle, for example, okay, this is x degrees and this y degrees. Okay. So what is the difference between these two? How they are related? Okay. One angle is 24 degrees less means cancelling, 24 degrees less than twice of the smallest angle, let us take the smallest angle as y. 2y minus 24, right? So we need to find, we have one more relation, x plus y should be equal to 180. Adjacent angles should be 180 degrees. And this is x minus 2y is equal to minus 24. Subtract these two, we'll get 3y is equal to 180. 180 plus 24, that becomes 204. And y is equal to 3, 6, 18. 2 and 6 8s, 3 8s are 24, right? Y is 48. If y is 68, if y is 68, 2 times of 68 minus 24, that becomes 8 to 16, 6 to 12, that 136 minus 24, which is 112, right? So 112 and 68, 10, 6, 7, 8, 180. That's exactly right. So if one angle y value is 68, we came to know that 68, the remaining angles are very easy. This is 112, this is again 68, opposite sides are equal, and this is again 112. Right? So that is how you can try to bring all the values, all the relations here. 24 degrees less, whenever you see the name, the word less, you need to subtract. 24 degrees less means you need to subtract 24 degrees less than the twice of the smallest angle, okay? So moving ahead, the midpoint theorem of triangle, which is again a very important theorem, and there are lots of applications based on all this, right? So what is the midpoint theorem? States that in a line segment joining the midpoints of two sides of a triangle, the line segment joining two midpoints of the sides of the triangle ABC, and let us say this PQ, this is the midpoint, okay? Midpoints of two sides of triangle is parallel to the third side and also half of it. What is that? So it is a parallel to the third side. So PQ is parallel to BC. PQ is parallel to BC and also half of it. So BC or PQ is equal to half of BC. PQ is equal to half of BC, right? The line segment joining the midpoints of two sides of a triangle is parallel to the third side and also half of it, right? And this is very important application for many questions. This will be applicable and we can directly solve the answer. The converse midpoint theorem, just now we discussed about midpoint theorem. So there is a converse for the same theorem. What is that? The line drawn through the midpoint of one of the sides of a triangle and parallel to the another side will bisect the third side. Okay, that means it bisects each other. So this one and this one are equal. Once again, the line drawn through the midpoint of one side, that means these two are equal. Midpoint of one of the sides of the triangle and parallel to another side will bisect the third side. Right? So let's move for the next one. ABCD is a square. E, F, G and H are the midpoints of AB, BC, CD and D respectively, such that AE is equal to BF is equal to CG equal to DH. Prove that EFGH is a square. What is that? Once again, ABCD is a square. ABCD is a square. EFGH are the midpoints of sides AB. For ABE, next BC, EFGH. EFGH, right? So if you add these four, so now we need to be very sure with the calculations such that AE is equal to BF is equal to CG equal to DH. So all this AE is equal to BF is equal to CG is equal to DH. Okay, so all these are equal. Prove that EFHG is a square. Now what we'll do? Okay, so let's try to take a diagonal. Let's try to take one of the diagonal. Okay. So what happened here? One second. Or let's try to do this one. Yeah, let's try to take if you join these two sides. E, F, G, H. See carefully. Or what we'll do? E, F. One second. I'll just let me draw that properly once again. ABC is a square. ABCD. One second. ABCD is a square. And E, F, G and H are the midpoints of AB. E, F, G, H are the midpoints of AB, BC, CD and DA respectively. Show that AE, where is AE? AE is this one, right? So AE, BF, AEBF, okay, and CG and DH, these two are equal, right? Such that these four are already equal. We need to prove that EFGH is a square. So EFHG. So this one should be a square. Okay, right. So now carefully observe. We have a lot of triangles here, and just now we discussed about midpoint formula. We already have a midpoint here, correct? So let me join these two. Right? Let me join these two. Now what we need to prove? We need to prove that EFGH is a square. When I want to prove that, let me first of all find at least the opposite sides are equal. At least let me show that the opposite sides are equal. Okay. So how can we do that? Once again, let's go back to basic proportionality theorem. Midpoint theorem. Yeah. The line segment joining the midpoints of two sides of a triangle is parallel to the third side and also half of it. Is parallel to third side and also half of it, right? So based on that relation, you can try to do this one. So this side is the side of the triangle. If you take if you take the diagonal of this is one diagonal and the other diagonal, right? So what we can do, it is exactly half of that. See, yeah, or else we'll try to solve this in the coming class. Okay, there is some logic that we are missing here. So let's try to solve that in the coming class. Let's move for the next question. Okay, I'm missing some point here. Let's not waste the time here. So that AE is equal to BF is equal to, we need to prove, it's already given AE, and what we can do here, if AE is equal to BF, okay, given ABCD is a square, so even this will be equal, but we need to show that, prove that EFGH is a square. For that, it is enough to show that at least opposite sides are equal, correct? Okay. We did the mistake. We are not taking the diagonals of a square. That is the mistake I'm doing from last time also, right? We are not taking the diagonals of the square. 1 second. ABCD is a square, ABCD is a square, and EFGH at the midpoints. Now, what the mistake I'm doing is, we are not taking the diagonals of a square. We need to take the diagonals of a square, which will help us in getting this one. Okay. So if you carefully observe for EF, okay, once again, let's say these two, let's try to join this. Okay. So EF and AC, using the midpoint theorem, EF is exactly half of AC, right? Carefully observe, draw the triangles, draw the basic things. Okay, if you can observe like this, ACB is a triangle. The triangle ACB, in triangle ACB, okay, so this is the midpoint and this is midpoint. So EF will be exactly half of AC. EF will be exactly half of AC, correct? In the same way as we got EF, we can also get FG. We can also get FG, right, using the other diagonal, which is half of BD, and again in square the diagonal lengths are equal. So half times of AC, we can write like that as half times of AC, right? In the same way, if you go for GH, the same way if you go for GH is again half of AC. In the same way, if you go for EH, right, which is exactly half of BD, which is again equal to half of AC. So if you can observe this one, all the diagonals are equal. So all the sides are equal now for the figure EFGH. But once again, don't worry. Once again, we are going to discuss that clearly in tomorrow's class. Okay. I'm telling you one thing, you just need to take care of a few triangles. Okay, there's a triangle, there's a midpoint. You need to see EF is exactly half of AC. In the same way, FG is exactly half of BD. So we have a lot of triangles in that to understand, which once again we'll start in tomorrow's class. Okay, so after that we have a couple of more relations. What have we discussed? Let's try to understand this one. Okay, the diagonal of a parallelogram divides it into two congruent triangles. Yes. The diagonal of a parallelogram divides it into two congruent triangles. Next one, The opposite sides and angles of a parallelogram are equal. Opposite sides and angles of a parallelogram. Okay, so this side and this side is equal, and angles, opposite angles are also equal, right? If each pair of opposite sides of a quadrilateral equal, then it is a parallelogram. If each pair of opposite sides of a quadrilateral are equal, then it is a parallelogram. Okay, that's straightforward notation. If each pair of opposite angles are equal, then it is a parallelogram. Yes. Diagonals of a parallelogram bisect each other. Yes, that's correct. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Okay, so those are the beautiful points that we have discussed till now. In the coming class, we're going with the next chapter, and we'll also come back with more applications based on all these geometrical concepts. Right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone, so now we'll be discussing about pressure in liquids. Okay, so my name is Seshan Reddy, I'm a graduate from IIT Dhanbad. Let's go into the class. So first of all, a very simple question for us, that is, why do deep sea divers wear special suits? You can see that here. We can see a diver, an image of a diver, and you can see is completely covered in a specially designed suit. Why? Why is that? I mean, some of you might say, sir, for breathing purposes. For breathing, he needs an oxygen tank. There is an oxygen tank. He has a mask. That should be enough. But why does he need a special suit? That is a question. And the answer is to withstand the pressure of water. So as you go deep into the water, the pressure increases. And who applies that pressure? Water applies that pressure, and water is a liquid. Right, so water, that means liquids, can apply pressure. Right, and we know the formula for pressure by a solid, it is what? Pressure is equal to force by area, and when we say force, that would be thrust. So pressure is equal to thrust by area. The same formula will also be applicable in the case of liquids also. But when it comes to pressure by liquids, there are some interesting properties. Interesting characteristics of that pressure. Right, what are they? Let's go into that. The first one is liquids exert pressure on the walls of the container. Now you're talking about liquids here, yes or no? So here, if this is the container, let's say this is the container. Okay, and in the container there is, let's say, water. Right, there is water. Now if I make a hole anywhere, let's say we make a hole here. What happens? If you make a hole, water will come out. Obviously water will come out, sir. Water will fall down. The question is why? Why does the water come out? Because water is pushed out. That is, there is a pressure there. So because of the water pressure, it comes out. That means even when there is no hole, what happens is the liquid will be exerting pressure on the walls of the container. And how will the pressure be? It will be pushing it out. Water comes out, so it is pushing it out. So there will be an outward pressure on the walls of container. Outward pressure on the walls of container. Got it? Then, look at this. At the same height, pressure exerted is equal at all points. The same height, pressure exerted is equal at all points. So what does that mean? What that means is, again if I take, let's say, another container. Right, this is water or any liquid for that purpose. Now if I take these 2 points, I'll take these 2 points, point A and point B. Look at that. Are they at the same level? When I say at the same level, look at the depth. Are the depth of A and the depth of B equal? They are equal. The depth of A and the depth of B are equal. That means that the same horizontal level. They are at the same horizontal level, right? So whenever there are points at the same horizontal level, then pressure at A will be equal to pressure at B. And why only A and B? You can take any point. You can take a point C, you can take a point D, you can take a point P, any point on the same level. When I say level, the same horizontal level, pressure will be equal. Pressure will be equal. Got it? So all the points pressure is equal on the same horizontal level. But if I take another point, let's say here, if I take it as Q, then obviously pressure at A is not equal to pressure at Q. Why is that? Because A and Q are not at the same level. They are different depths. And even horizontally, they are at different levels. So that means at A and at Q, pressure will not be equal. Good. Interesting point, right? So the second one is also done. Then what else do we have? 1 minute. Third point, the pressure exerted by liquids increases with increase in depth from the surface. That is the reason why deep sea divers have to wear special suits. Right, if I take that into consideration, what that means is, if I take another container here, and let's say if I take 2 points in the liquid, I'll take 1 point here A, another point here B, let's say I'll take another point C. So if you look at the depth of A is less than depth of B is less than depth of C, right? Different depth of A, depth of B and depth of C. Now pressure increases with increase in depth. So as you go down, pressure is increasing. So what it means is pressure at C, the greatest depth, is greater than pressure at B is greater than pressure at A. C, B, A. C, B, A. That's how the order is. As you go down, as depth increases, it increases. It's simple, right? It's easy to understand also. As you keep going down, the weight of water that you carry on you will increase. If you are swimming, if you are inside water, there is water above you. Understand this. If you are here, let's say this is you. You are swimming, that means you should be carrying, right, this much of water. You are carrying it, your body is carrying it in simple way of understanding. So obviously as you go down, the amount of water you carry increases. And that means the pressure exerted by water on you also increases. Good? Okay. Then, that point is also done. And for the same point, for the third point that we just discussed, there is another way of understanding it. Just look at the animation. See here we have 3 holes, A, B and C, like, right? Let me call it A, B and C. A, B and C. You can clearly see that the water from C is going the longest. Water from point C is going the longest. Now the question is, why is that? Because the pressure of water at C will be greater. Pressure at C greater than pressure at B, greater than pressure at A, because as depth increases, depth of C will be more than depth of B will be more than depth of A, and depth increases, pressure increases. This is the order, and hence water from C travels or falls the longest. Okay, good. And then pressure at the same depth is different in different liquids. And obviously it has to do with what? It has to do with weight. Now let's say if you are swimming in a pool of honey. In a pool of honey, imagine. Okay, just imagine you are swimming in a pool of honey. Just a minute. Just a minute. Imagine you are swimming in a pool of honey. Then the weight that you will be carrying is of the honey. If you're in water, you'll be carrying water. If you're in honey, you'll be carrying honey above you. Right? That means the weight of water will be different from weight of honey. Yes or no? And if weights are different, automatically the pressure exerted will be different. So the pressure exerted will also depend on the type of liquid. Will depend on what? The type of liquid also. So these are some interesting points regarding the pressure exerted by a liquid. We'll again go through them. All the points are important, by the way. The first point is liquids exert pressure on the walls of container. It is an outward pressure. They push the walls. Second, at the same height, the same horizontal level, the pressure exerted is equal at all points. The pressure exerted by liquid increases with increase in depth. And it is also what? It is different in different liquids. That means the pressure exerted by a liquid will depend on what? Will depend on the type of liquid. Fourth point. It will depend on type of liquid. Different liquid, different pressure. So pressure exerted by a liquid will depend on the type of liquid. And third point will depend on the depth also. The depth also. Alright? Okay, wonderful. Let's continue. So we understood those points. So let's go into a very simple question regarding that. What is the question here? The question is this. A container filled with liquid as shown in the below figure. You can see the figure. Which of the following statements is correct about pressure of liquid? Which of the following statements is correct about pressure of liquid? You have 4 options. Go through them very carefully. I'll give you how much time? 30 seconds of time. I'm not going with a timer. I'll just look into it in my watch. 30 seconds of time. So please solve it. Look at them and then give the relation between pressure at A, pressure at B and pressure at C. And the time is up. Right, so you have 3 points here. C, B and A. Let's say A is here. Let's say A is here. B is here. C is here. If I look at the depth, then obviously depth of C is greater than depth of B is greater than depth of A. Right, depth of C greater than depth of B greater than depth of A. And as depth increases, pressure exerted by liquid increases. That means pressure at C is greater than pressure at B is greater than pressure at A. That is the correct relationship, and we just have to look at the options. And it would be option B, C, B, A. Got it? Very simple. Wonderful. Let's continue. Now let's try to get a formula for pressure exerted by a liquid. The formula for pressure exerted by a liquid. So what we'll do is, it's already given here. We'll take a container filled with any liquid. It could be any liquid, water, honey, alcohol, mercury, anyone. What I'll do is, we'll take a small element. We'll say a small cylinder-like shape here. And that cylinder is not something separate. It is nothing but that cylinder is completely the liquid itself. We have taken it as complete liquid itself. Okay. So here, consider a cylindrical element of the liquid. Okay. Now, cylinder will make it easier to do it. That's why we are taking cylinder. Now what I'll do is, this area I'll call it as A. The area of this circular face, we are calling it as A. So let A be what? Area of the circular face. Area of the circular face. And here at the top, there is what? It's the surface, and this other surface is at a depth h. So what is h? H is the depth. And let's say P atm is the atmospheric pressure. Is the atmospheric pressure. And where will the atmospheric pressure act? Because see here, when I look at the cylinder, or when I just look at the liquid itself here, at the surface there is atmosphere. So which pressure should be acting at the surface? At the surface, atmospheric pressure, because above the liquid surface there is atmosphere. And atmosphere applies a pressure. That is why we talk about atmospheric pressure. Atmospheric pressure. So you have A as the area of circular face, H as the depth, and that is that. Good. Now understand this. Pressure by liquid is always a pushing force. Always. So here if I take this cylinder, that cylindrical element, what are the forces acting on it? What are the forces acting? One force will be force due to atmospheric pressure. How do you get the force? Force is equal to pressure into area. At the top you have atmospheric pressure. So atmospheric pressure into area. We have taken area as what? See here, we have taken area as capital A. So that's why I'll just use the force as what? P atm into A. So the forces acting, the first force will be P atm, pressure into area. And how is it acting? It is acting downwards. It's a very interesting and a very simple derivation. Then what other force will be acting? See, that cylinder is nothing but completely water. Right, and water has mass, and if there is mass, there is gravitational force. So you can also say that there is gravitational force, mg. That is also downwards, mg downwards. Got it? Now, see here, then what else? Then from the bottom, see at the bottom there is liquid. What that liquid does is it applies an upward force. Because as I told you, pressure by liquids always pushes it. Pushes the object, so it is applying what? An upward force. And there let's say the pressure is P. So the force will be pressure into area. The force will be pressure into area. And how does it act? It is upwards. Now that water is at rest. Okay, we have taken a cylinder. The liquid is at rest. The liquid is completely at rest. The liquid is not moving. That means net force is 0. The forces are balanced. The forces are balanced. And if they are balanced, what does that mean? Total downward force will be equal to total upward force. So if I add these two, it should be equal to this. So pressure into area, upward force, is equal to P atm into A plus mg. Mg is also a downward force, and let's call it as equation 1. So we got the forces acting here and we got a relation between them. Our target is to find P. Our target is to find a formula for pressure P. Now for that, what we will do is, the next step, we will write mass m in a different terms. Okay. And first of all, what is m here? M is what? Mass of liquid in cylinder. Mass of liquid in cylinder. What is P here? P is pressure here. And what? It is at pressure at what? Pressure at depth h. Pressure. By whom? By liquid. At which depth? At depth h. Got it? Okay, let's continue. So now, let that equation 1 be there itself. Now we'll go into the mass of the liquid. Now it's a very simple form of writing it down. Now what is mass? Mass, as we know, is equal density into volume. Why? Because density, rho, this symbol is for density. Density, you can use any symbol, I'll use rho. Density rho is equal to what? Mass upon volume. Yes or no? Density is mass upon volume. So mass will be equal to density into volume. And this is what? It's a Greek symbol. It's a Greek symbol called as RHO, rho. Okay, spelled as RHO and it's pronounced as rho. Simple. So mass, as we know, is density into volume. And we are talking about mass of liquid. So rho is whose density? Rho will be density of liquid itself. Very important. So I'll call it as rho L. So that you will not have any confusion. It is density of liquid. And what is V? V is the volume. But what is volume of cylinder? Volume of cylinder will be equal to area into height. Yes or no? If this is a cylinder, this is area A, the height is h. The height is h. So volume will be equal to area into height. Area into height. So we have mass and we have volume. We have mass and we have volume. Is that clear? Good. Very good. Then we'll combine these two. In place of volume, I'll use A into H. So if I combine these two, what does it become? Mass is equal to, in place of rho into, in place of volume, AH. I'll just use M is equal to rho AH. It is not the final formula, nothing. It's just a step in the calculation. And then we got the mass. Now what will mg become equal to? The weight mg will become equal to m into g. M is rho ah. So it becomes rho ah into g. Let us call this as equation 2. Now let's do. We haven't done anything much complicated. Very simple. Density mass by volume. We got mass in terms of density. Right? Mass is equal to density into volume. Then we expressed volume in terms of area and height. And then we combined all of them. That's it. So what we will do is we'll use this mg in equation 1. In equation 1 we have mg. We will use that mg, the equation 2 here. So if I combine 1 and 2, let's say 2 in 1, equation 2 in 1, what does that become? Equation 1 is PA is equal to PATM into A plus mg. But in place of plus mg, what I'll do is I'll use, what is equation 2? Rho AHG. And here you have PA. Okay, good. Now if you can see clearly, in every term you have area. Area A. So in all of them area will be cancelled. In all of them area will be cancelled, and what will remain? Pressure at a depth h. P is equal to the atmospheric pressure plus rho GH. Rho HG, I'm writing it as rho GH. This is the formula. So pressure at a depth h in a liquid is atmospheric pressure plus rho GH. What is rho? Everyone, see, whenever you go into a formula, it's very important that you understand what the quantities mean, what the variables mean. Very clearly that too. So here rho is density, but density of whom? Density of liquid itself. You have to be very, very, very careful. G, as we know, is acceleration due to gravity. H is the depth. P ATM itself, atmospheric pressure. And P is the pressure at that particular depth H. This is the formula. Clear? And this formula clearly shows us that if H increases, this value will increase. If that value will increase, it's an addition. So the complete value increases. So H increases, pressure increases. H increases, pressure increases. Got it? Good. So we got the formula. As simple as that. So the same formula is given here. You can go through that. Clear? Good. So now we also got a formula. So all that you have to understand is pressure at any depth h. If I take any container, this is surface at any depth h, at any point, let's say this is the point A. If I need the depth, the pressure at A, get the depth, and pressure at A will be equal to atmospheric pressure plus rho g h. Rho, density of liquid, g, acceleration due to gravity, h, the depth of that point. As simple as that. Good? Okay. So let's go into a few questions then. Also, there's one more point here. Just a minute, let's tell that to you. Here you can easily see that in the rho g h you have rho. Rho is density of liquid. So if you use a denser liquid, or that is if density increases, automatically this complete quantity increases. So pressure will also increase. Pressure will also increase. So you can say as density increases, pressure also increases. And density depends on the liquid. If you take a denser liquid at the same depth, pressure will be greater in the denser liquid itself. Good. This is done. Let's go into that problem. This is the first problem. Very simple one. At the same depth, which of the following liquids exert a greater pressure? And we have a few options: oil, water, milk, and mercury. I'll give you 15 seconds. Very simple, 15 seconds. Please answer this. At the same depth, which of the following will exert a greater pressure? Everyone, 3, 2, 1, and 0. The time is up, and the correct answer is D, because greater the density, greater the pressure. Greater the density of liquid, greater is the pressure. And here among the given options, among the given liquids, which one is the densest? Mercury is the densest among all of them. That is the reason why mercury, the answer is mercury. Mercury is the densest among the options given here. As simple as that. Good? Okay. Now let's go into next question also. Now it's a numerical. Calculate the pressure due to a mercury column of 76 centimeter given that the density of mercury is 13.6 into 10 power 3 kilogram per meter cube. Now what are they asking? Now when they say mercury column, so it's you have a vertical column. Something like this. You can imagine a cylinder. That cylinder is completely filled with mercury. And what is this? This is 76 centimeter. The depth is 76 centimeter. And we assume that the atmospheric pressure is 0 because we need only the pressure due to the mercury column. We don't want atmospheric pressure, nothing like that. Only this. So what is the given information here? Given information is height is equal to 76 centimeter. What is 76 centimeter? I can write it as 76 by 100 meters. We can. 76 by 100 meters. Then density of mercury is given as what? 13.6 into 10 power 3 kilogram per meter cube. That means it would be 13600 kilogram per meter cube. So you have height, you have density, you have to get the pressure. How do you get the pressure? The pressure P is equal to rho GH. What is rho? 13600. into G. G is 9.8, but for convenience sake, I'll take it as 10 meter per second square. We have to, exactly speaking, you have to take it as 9.8, but for convenience, I'll take it as 10. And height is 76 by 100. See, everything I'm taking in SI units. All of them have been taken in SI units. The final answer will also be in SI units, and the SI unit of pressure is Pascal. Right? Okay. So here you can do the calculation. What happens here? 0, 0 cancel. 1, 0, 1, 0 cancel. It is 1360 into 76. 1360 into 76. You can multiply that, yes. 136 into 76. 6, 6, 36, 816. 7, 6 are 42, 4 carry 7, 21, 25, 2 carry 9, 52, 6, 3, 8 plus 5, 13, 10336. And what is that? 10360 Pascal. And here, look at this. If I want to write it in terms of, let's say, into 10 power something. Decimal is here. If I move it by 1, 2, 3, 4, 5 decimal places to the left, I should write it as what? I should write it as 1.033 into 10 power 6 Pascal. 10 power 5. We are moving it by 5 places, not 6 places. And hence, the answer is 10 power 5 Pascal. Clear? So, it's very simple. I use the formula P is equal to rho GH. We are not considering atmospheric pressure here because it is clearly mentioned that we just need pressure due to a mercury column of 76 centimeter. So, we are not including the atmospheric pressure. Got it? There you have it. That is the answer. Okay? Okay. Good. Now, another question here. But again, a similar numeric. Calculate the pressure due to a water column. Previously, you had mercury, but now we have a water column of 76 centimeter. Given that the density of water is 10 power 3 kilogram per meter cube. So, if you write down the given information, the height or the depth is given as 76 centimeter, which is again as usual 76 by 100 meters. Then density of water is given as 10 power 3 kilogram per meter cube. Power 3 will mean 3 zeros. That is 1000 kilogram per meter cube. You have density and you have height. All that we need is to find out what? Pressure P is equal to rho GH. Rho is 1000. G will take it as 10. G will take it as 10 meter per second square. And H is 76 by 100. There you have it. Do the calculation. We should get the answer. 0 zeros cancel. So it remains what? It is 7600 Pascal or 7.6 into 10 power 3 Pascal. Right? And you can clearly see the difference in this answer and in this answer. This is in the case of mercury and this is in the case of what? In the case of water. Same height, same column, but different pressures due to different densities. Okay, so that's it everyone. That's it for today. We have learned about pressure due to a liquid at a particular depth. Right, okay, so thank you. Thanks a lot.